This is from the unit circle worksheet, and we're going to look at question number 3A. So 3A says, determine the x and y coordinates on the unit circle to define the terminal arm of angle theta. So for A, if we draw this picture, 3 pi over 4 is right there, and we want to know the coordinates of that point if we're in a unit circle. Now, the one thing, basically this is just a definition, because once we understand that the unit circle gives us, or the coordinates on the unit circle are the same as cosine of theta and sine of theta, we can just give them the cosine and sine values. So if I just write this out, I know this is going to be 1 over root 2, 1 over root 2, and that gives us the position x equals 1 over root 2, y equals 1 over root 2. But more generally speaking, we can say that if it's a radius 1, we can say that this length, or not just the length, but the position is going to be determined by cosine 3 pi over 4. And this length here, or more concisely the position, is going to be given by sine of that same angle. The sine gives us the y coordinate, the cos gives us the x coordinate. So that said, we can take a look at question F. So I can then just generalize then. The coordinate on this unit circle for this angle of, that angle is going to be 4.05, so maybe somewhere around there. That coordinate is just going to be given by cosine of 4.05 and sine of 4.05. We can just plug that into our calculator to work that out. So we're plugging into my calculator. I take the cosine of 4.05 and I get a position on the unit circle. Remember, this is a unit circle. It has to be radius 1, 0.997, or I'm going to round that to 998, and then do the same thing. I'm just going to do 4.05, and then take the sine of that, and that's going to give me the vertical positioning of that point, and that's going to be, okay, hold on here, 4.05, okay, and